Hey everybody, it's been a while since I've done a recording on Guardian. A lot of things have changed. I'm actually currently going through and making changes now, and I decided I wasn't gonna record. I'm just gonna go and work through it, and then I decided, you know what? Let's do a programming session. Now, mind you, you'll notice that there's this Copilot chat over here, but I won't be using it because I've decided, I've gotten so accustomed to using the chat bot, that I feel like I'm losing my skill. You know what I'm saying? So I've decided to not turn it off. It's still available, but I'm not actually going to use it. In fact, I'm going to do the following to give myself more room. So I'm working through permissions here. If you've noticed, is guest permission, is user permission, that kind of stuff. Um, there's a lot of work. So this is what I have so far. So where do I begin? Um, no, that's not what I wanted. Hold on a minute. Let me get situated here. Okay. So there's been a lot of changes to Guardian since the last video. And I'm going to show you that in a minute. Um, I, I don't have any old code to show you how it was before. But let's just go with what I've built. So initially, all somebody had to do, like let's say somebody wanted to call is valid tier, right? This function here. Before, all you had to know was a permission, okay? Permission. So, if I know the program and I want to call this to see if I have a valid tier and I'm a guest. So, before, all I'd have to do is type in permission for two semicolons and then whatever I wanted to pull from this list. And that would be my security passcode. That would be my access pass, right? And I thought about it and I was like, man, that is not safe. So that means basically anybody can call this function, give themselves system permissions, and go and wreak havoc in the system. And then I got to thinking, man, that's not a good idea. So what I did then, after building permission and target tier, is I built the security authority, the security manager, well, that's later, and the auth token. So here's security authority. It's the only one that can create these tokens. This is a token. So we have a target tier, which is the tier identity, unknown flags, which it's set to unknown as default. Permission, no permission for as default, and it's got a token secret. The secret, which is validated by the target permission handler, that is something I'll show you later. The token also has identity flags. It determines whether it's a system token, an admin token, a user token, a guest token, a quarantine token, a blocked token, a revoked token, and also a flag for true or false, whether or not it's a valid token, valid authority token. And then we have a private constructor, and that's because I set this up so that no one but security authority, right? So you'll notice here, friend class, security authority, friend class, it's a friend of this class, security authority, which is this baby right here, security authority. Okay? So only the security authority can issue a token. And I'll show you that part in a minute. So we also have the authority manager, and I'll show you that. That's something I kind of I was kind of excited. It's something I spinned off because I originally the security authority was like giving the tokens and doing everything, and I split it up, and I'll show you that in a minute. So then it has the default constructor, but is it system false? Is it valid? No. So even if you try to create a token outright without using the specified way, it's not going to be an authorized, it's not a valid token. It won't be usable. Forced. And then of course there's a function down here to validate whether or not it's a valid function or a valid token. So I talked about authority manager because originally security authority was like the centralized thing that generated the key, the random key and all of that. And I was like, no, man, I need to do something different. So authority manager is unique. It has 3 subclasses built into it. This is so the first part is the internal encryption. It holds a pre-built system tier auth token for internal gating. It's constructed with a pre-computed secret. It never holds the raw master secret. So the internal encryption has this. It literally just verifies that the it's a valid a validation process. Okay, so that's the internal encryption. The security statistics, this is just like, total tokens issued, system tokens issued, admin tokens issued, down the list. Time series, system tokens over time, all the way down to unknown tokens over time. Then it has a maximum history length, a time window, and then it's a start time. That's all timing information. So I can like start and stop time type thing. And then, of course, the authority manager is a friend of security statistics so that the authority manager is the only one that can construct it. So the authority manager, sorry, my tongue is tied, is all of this. So here's the Sentinel Authority. It's an automated AI assistant for mapping the authority's internal state, token generation, and verification logic. Ensures consistent and secure handling of credentials. And that's this. Of course, it computes the secret. It's got it accepted as valid by the verifier for each tier. And then after Sentinel Authority, the comments kind of explain everything. That's why I'm kind of staying quiet. I'm just kind of showing you everything. So that's the authority manager. I don't really want to show you too much because it's my baby and I love it, and I'm still building her. It's crazy. So then it goes on to that security authority that I was talking about, which is the only place that can issue tokens. And here's the logic for... So what I have created here, the security authority, is not something that's called all the time, right? It's set up once. It's this instance function here allows you to only have to call it one time. And here's the logic for that. Okay, so that's the instance. And now, if this is centralized, so this is calling the manager, right? So let's take a look at that create token and see what it does. because it's obviously another function that's called here. So let's go back up all the way up. Whoa, too far. Let's close auth token. We don't need that anymore. Authority manager. Okay. Authority manager. Okay. It says create token. So maybe I will go ahead and show it to you. Show this to you. So it starts by asking if the sentinel's ready. Yeah, this is too creepy. I understand. If the sentinel's not ready, it returns, you know, the create token function will automatically just create a bad token. However, if the secret is the computed secret, it's time to create a token. But what we need to create a token based on what tier, what level is wanting to access the system here. So we use a switch, and we using this target tier perimeter, which I'm probably honestly going to add more security to this because this is a system function. This is something that, and I don't know how I'm going to do that though. That's something I'm gonna have to work out. Because I feel like there needs to be like some kind of verification. Because this is a system. I don't know. I'll have to look at it more. Anyway, so what it does is it looks through this tier, and if you are asking for, if you're creating a token of system, it will create it. And you know what? On second thought, I'm not going to put anything different here because it's gated somewhere else. Gated meaning only system or administrator can use that function. It's a security thing that I'm creating. So anyways, like I said, it basically creates the token based on what privilege you need. Okay, so that's security authority. So that's return manager, create token. And then you got system, admin, user, guest, quarantine, block, revoke, and unknown. And these are all tokens that can be created. Right? So then that's the security authority, which is the only place tokens can be tokens. These auth tokens, these bad boys, these can only be created here. Okay? And they are verified in the target permission handler. And that's done by the following. So we'll start with this. And obviously, you can tell this is, I mean, it's got the token perimeter, right? But I have no way to, like, wait, do I? I know what I need to do. Wait a minute. I don't know. I'm gonna have to work on that. That's I mean, anyone can call that. There's no gate. There's no way to protect. Anyway, so these are like functions to verify the token. Okay. So wait a minute. I'm lost in my own code. See, this is the problem, guys. Oh my gosh. But yeah, no. So basically, the target permission handler is kind of like where it can verify the token. Okay. Notice verify system token, verify system token. And I need to find a way to gate this, right? Because notice, this is what I mean by gated. Okay. Is valid tier. Okay. That's the first function I wanted to show you. Okay. It's a is valid tier. It's defined over here. Where are you at? Oh, here we are at line 835. Right. So what this is this is where you can declare it in a header and define it in a CPP file. A CPP file. It's funny to say that. No, it's a source file, and that's what's compiled into the program. It's another way to write code. It makes it easier to combine things together by doing this. So anyway, that's beyond the scope of what I'm trying to explain here. So like I've said here, I got this function defined here and actually created over here. This is a way you can create things. But you notice, what's the difference between this function, which has no verification, and this function? Notice anything different? Any drastic changes? So, for those that may not understand what's going on here. So, I have a function. It's a Boolean, which means true or false, yes or no. And at line 161 here, I have an if statement. And it's calling verify user admin and system to either or, right? These two lines that indicates or. That means verify system token or verify admin token. That's basically means either it's a system token or an admin token. It can reveal this information. Then it continues with an else if. If it's a user token, which has read and write permissions only, and they're the target tier of user, then they can validate user and guest tiers, and guest is like read only. And then if it's a blocked token or a revoked token or a quarantined token, they get nothing. They get no information, because why would I want to expose anything to them? They're trying to get in and be malicious. So that's why they're in quarantine, or that's why they've been blocked. So that's one. So is deny tier. Here's another one. But this one, it's just making sure it just returns block or revoke, which are just tiers that I have created in the system. Oh, and basically what I'm trying to get out of this whole thing here, there's a lot going on here, as you can clearly tell, right? There's a lot going on. Okay, so it's basically an authority token that has its own. It doesn't have it in the actual token itself, but it has a secret. It's basically a hexadecimal number that's completely random and completely, which I don't think it's actually completely random. Something I need to work on. But it's each token gets its own number or its own specialized key. That key will unlock certain functions in the program. So that's what I have so far, and it's been I tell you, it's a beast. I mean, I just keep adding stuff to it, because originally there was none of this. The target permission handler, this was an access control entry, and it didn't have nearly as much stuff as it does now. So this is just another way. This is the permission handler, and this is the access control protocol, which goes into more information and more functions. And of course, these are all functions inside. And then after the access control protocol, which is kind of like the heart of everything here, we go into registry information. And so there's a registry change record, a singular ACP. So basically, from this point on, it's going into more in-depth stuff. So like a registry entry. And of course, these functions are defined over here in the CPP. All right, that's the registry entry. And then it goes down to a security descriptor. And anywhere you see like a semicolon here but no function body, that's a declaration. That means everything is over here. See? Everything is over here in the CPP file. So then after this security descriptor, we have an audit record. And the comments are pretty self-explanatory. That's why I'm not speaking much. I'm just kind of letting you kind of glance over it. And that's everything for this for the security or for the audit record. Then there's a registry policy. And of course, that is everything in the header for registry policy. Feature policy binding is another feature of this program. And then, of course, registry statistics. And then this was something I had recently added, and because I want to show you another file. Hold on, me gotta pull this out. Whoop. Solution Explorer, because in the next file down, we've got this notion of a user profile, system administrator, system user. And right now, that's all it is, right? But eventually, it's going to have all of this security stuff some way intermingled into it. So what I did to do that, I did a skeleton key. What a skeleton key will allow me to do then is this is a centralized location for each user over here. So it'll do something like, I mean, I don't know if I'm actually going to keep this, but I'll do something like this. No, system key User. You know what? We're going to use a weak pointer. Sorry. That's not right. What do I want to do here? What do I want to do? Let's see. Not a skeleton key, because that's a... I can't do that. But with a user profile, because user profile... Another thing I want to show you. Hold on. User profile. System administrator. Notice? What that means is that system administrator inherits from user profile. Anything in the protected state or public will be usable. But you know what? Maybe I'm going to make this protected. System key. What's the constructor for a system key? Okay. Oh, I need a token. Oh, wait a minute. I know how to do this. Private. It would be auth token equals. Now, why are you doing what you're doing, AI? Stop that. Security authority. Generate system token. Is that how that works? Oh, why are you not working? Wait a minute. Oh, no, it's issue. It's issue, not generate. What are you telling me that what? Get rid of this. Causing issues. Ugh. Okay, why are you doing this to me? It's doing it to me because it knows it can. Oh, no, it worked. Okay, excellent. Okay, so now that I've created in the user profile, I've created the system token. It's private, which means only the user profile can access it. That means that people outside the user profile can't access it. Unless given permission to do so, which I really don't want to do that. So then, now why are you doing this to me? All right, ladies and gentlemen, I'm breaking down. I'm using AI. I'm stumped. I need help. Okay. Um, let's see what happens. Okay. See what it's got to say. I'm stumped. I need help. Because I thought that would create a token. Because that's what we looked at. Right? Hold on. Or am I just screwed up in the head? Which is quite possible too. Okay, hold on. Where are you at? No, it's issue system token. Why? Oh, wait a minute. Ah, hold on. I think I know what's going on. I think it's half the problem. I don't know. Hold on. That's oh. Oh. You must go through instance first. Now I feel special. I did that all in front of you, and now I feel really special. I'm the one that created it like this, and I'm still screwing it up. See, this is human error. Oh. Okay, so let's go ahead and do as it suggests. Okay. Okay, so let's try this. Why are you doing this, stupid? Okay. Hmm. But that's, yeah. Hang on. Okay. Okay. Hold on. So I was creating my own problem. Okay. Store a key. Issue tokens through the key. Okay. Huh. Okay. Hey, look at that. Thanks for saving my copy. Let's go ahead and make some changes here. Oh! All right. Now let's be smart about this. Let's get rid of that. And we really don't need this protected anymore either. This stuff actually, I'll leave it there for now. See, I'm getting ahead of myself now. That's awesome though. Okay, it's done. So like I can do stuff like that. So now the user has a token that can be used anywhere in the system. Now, but that's not what I'm actually working on. I'm gonna go ahead and save that file. Save. You are annoying. It still don't work, but that's okay. So anyways, that was the only help I needed. Pretty big though. Let's see. So that's pretty much all. I'm oh, I wanted to show you the registry. So there's not just a skeleton key, there's a system key, an admin key, a user get key, a guest key, quarantine, block, and revoke. And those are all used. So as you can see in O3, they've got this session manager, a user profile, but I don't have that before the control registry. And I wanted some way for the users to have some way to control the registry, the control registry here. And as you'll see, that's even more stuff. This is where we're going to stop today because I still have a lot of work to do. So I'm just kind of showing you what we're going to get through today. And that's it. I mean, there's a lot more, right? There's policy configuration, threat indicators, access pattern, security policy, access pattern manager, firewall decision, rate limit state, security manager. I mean, there's a lot of work here. There's really not that many lines. This is actually a small file in comparison to many others. So what I've been working on today is I'm making it more secure. So what does that mean? That means, remember, hold on. See, I'm already lost. Like this get key permissions. There's no way to prevent anyone from calling that. Oh, I've got so much work. So what I've been working on, I should say, is making it secure. Let's go ahead and get rid of that. Get rid of that. here's where I was. Okay. So this is like the old style, right? And this is what's changed too. So what I'm going to do here is I'm going to AI is trying to help me, even though I'm not asking it for it. Ah, really? No, go away. Ah. And that's how you update the function to make it safe and secure. That's one down. Hundreds more to go. One by one. Oh, oh. Okay. I think that's all for today. I think I don't want to bore you with my actual typing, but now you know what I have to go through, and I don't know. Is it time to play a game yet? Is it time to go to something else? No, but I do enjoy it. Otherwise, I wouldn't do it. But that's all for now.